Hello. I hope your day's been swell. I am filming this 5th episode of the Let's World Build series before I've even finished editing the last episode. And that's because I won't have the opportunity to make a recording like this for the next couple of weeks. So I'm just going to record this right now, and then this video will probably go out in like a week after I'm done filming this, so, But yes, this episode is hopefully going to be short. I want to make the episodes going forward pretty short, or at least relatively short compared to the other ones. Probably like 15 minutes, 10 to 15 minutes around there. Mainly because I've realized that making 30-minute episodes every time is time draining. It's mainly because of how I do my editing. I really scan through all the footage to make sure that I cut out everything that's boring and stuff like that. So a 30-minute video normally constitutes like 2 hours of footage, and 2 hours of footage is a lot of footage to scan through. So this will hopefully be a lot shorter. To enforce this, I am going to do something very short today. I am just going to fill out the Deca system with planets and asteroid belts and Kuiper-like belts and comets and dwarf planets and stuff like that. Shouldn't be too long, hopefully. So the first thing I should do is deal with the couple of notes that I have here. I made the words a bit bigger because they were a little bit hard to see, I imagine. So yeah. Hopefully this helps. First, I need to place the system within the dust lanes of the galaxy. That's something that I forgot to do last time, and it makes sense. So let me just add specifically within its dust lane. I think that's pretty good. So now we can start to go through some things. Okay, so first I just want to clean up this section, because, there's not going to be any nebulae or black holes or anything like that in this system, obviously. Moons are going to be around their respective planets, so moons will be listed in the planets sections. So I can delete that. There's no clusters, no clouds, nothing like that, so it's really only going to be belts. I'll fill the other regions out after I go through some stats, since this is a lot easier to do right now. The type of system that I'm going for is, well, obviously a stellar system, since it has a star in the center. Shape, generally a flat disk. I'm gonna get rid of anything other than the radius, and actually I'm going to make this radius to farthest out planet. So I'm gonna take a little trip to the Worldsmith here. I have in fact updated it to the latest version now, so that's good. And I copied over the star data, so we got that. And so now we got to get into the planetary system. And actually, I need to copy over the mass of the star, 1.26 solar masses. And this will inform a bunch of the orbit characteristics. So we have 10 planets. So the spreadsheet gives us a nice list of possible orbits for the planets. And these aren't exact. These don't have to be exact. These are just statistically what the spacing would look like in theory. I believe our own solar system's planets don't actually follow this sort of pattern exactly. So you can see that each orbit is around half of the one outside of it. I mean, you can see that this isn't exact, and it gets a bit more complicated the farther out you get. So with this list, we can basically pick and choose which orbits out of these that we want for the 10 planets. I can't delete any of these because I think that might mess up the formatting here. So I'm just going to highlight the orbits that I want. And then I'm not going to copy these values exactly. I'm going to make them a bit randomized. I'm going to add some noise to them, artificially, of course. I can change this value? Oh, it does inform the other ones. Okay, I did not realize that. So I enter the orbit of the first planet out from the star, and then the other ones, the other possible orbits, are informed from that. Gas giants may be placed in gray orbits here, which is good to know. First gray orbit will be the home of the system's largest gas giant. Yeah, the asteroid belt rules, which I will explain a bit later. Any orbit cannot fall within 0.15 AU of an adjacent orbit, Or else, there's some weird stuff that would happen with the orbits and there'd be a lot of interference. Maybe even planetary collisions. Ooh. But anyways, I do want a pretty inward planet, so I'm going to actually set this to 0.15 for the innermost planet. And I'm also going... Actually, I've just realized. Okay, so the problem here is that I don't have any habitable planets because the habitable zone is actually between these two planets, which is not good. Yeah, I'm going to have to put this farther out again. Okay, 0.4 AU does work, and I think I might just use that number, which is actually the number that it was originally at. So I'll actually add a 0.05 to that, and I think that's pretty good. And just so that there's no confusion with the highlighting, I'm going to make the confirmed planets in yellow. Okay, so I'm thinking I'll skip orbit 2 for no reason in particular, and then obviously we do need a habitable planet, so that one's going to be habitable. And now I'm deciding if I want to have an equal number of gas and terrestrial planets or more gas giants. Basically, do I want 5 and 6? Yeah, let's make things interesting. I'll have 5 terrestrial and 5 gas giant. I'll have a gas giant there. I'll skip one, put a gas giant there, skip a whole bunch of them, make those ones right next to each other, and now we have 4 gas giants, and then let's just one more. Let's make one really far out. I'll put the last one right there. I like that. So yeah, those are our 10 planets. So at the very least, there are going to be 2 asteroid belts, one between these planets and one outside of the farthest out planet, just like it is in our solar system. But due to the spacing here, since there's so much space right here, there might be a asteroid belt in this region, though it would probably more likely be like right here. I'm not exactly sure. Okay, and I actually need to inform this and say that instead of the outermost gas giant being 30 AU, it's actually 39,000 AU, which is actually an insane number. Like, this thing is so far out. Because I'm pretty sure Neptune, the farthest out gas giant for our sun, is only like right here. It's like in the 70s, I think. Like, it's nowhere near any of these numbers. So this planet is extremely far out. And so are these. So we've got some extremely cold planets over here. So this number informs where the debris disk is. And I imagine that it's going to be outside of the 39,000 number. So this is like a Kuiper belt sort of object, I believe. Let's look at the information. Yep, that's the Kuiper belt. Tons of dwarf planets can go in there, that sort of thing. And I'm going to use this 39,000 number for the radius of the system. Radius to the farthest out planet, 39322 AU. That's pretty good. And the mass, just like our own solar system, the mass is actually pretty simple. It's literally just around the mass of the star itself. Since for our own solar system, our sun constitutes like 99% of the mass or something like that. It's pretty crazy. So yeah, it's 1.26. And I'm actually not going to bother with volume or density right now, just because I don't feel like bothering with that. Motion is a little bit complicated because need to determine how fast this system is orbiting around the center of the galaxy, which could use some calculations. I don't know if the Worldsmith has a tool to determine this, so there's a chance that I might have to just leave this be, but I will look at that in a second. The rotational period is not really applicable since all the bodies are going to be going around at their own speeds. Parent orbital body would be the central black hole of the galaxy, which I haven't actually created yet. And I feel like I may as well just do that. Why not? I really like black holes. Black holes are really cool. So I'm going to open this up in a new tab. Black holes. And there's one at the center of this galaxy, but what should I name it? I'm going to give it a way over dramatic name, the Anchor. Well, most galaxies have a central black hole that sort of like give them their structure. I'm motioning with my hands, but you can't see that obviously. The central black holes give galaxies, an anchor. So it's a very straightforward name. I'm going to say that the parent orbital body is the anchor. And then these axes, I'm going to have to figure out at another time. Satellites, the system itself doesn't have any satellites, so that's not applicable. And actually, so I'm going to get back to this section in a moment, but I'm just going to deal with this stuff. All of these things aren't really applicable to a solar system, so I'm just going to delete them. Magic, there's no inherent magic, but I'm just going to clarify that. So there's no inherent magic to the system itself, and then the rest of this stuff, not really worth getting into since there's no organisms yet, there's no civilizations yet, stuff like that. So now to figure out the motion here, this sheet doesn't say anything about how fast the system is going around the galaxy or where to place it and stuff like that. So I'm just going to go back to Obsidian. So the ring radius, and actually this should be dust lane radius, is 32,000 light years. The Milky Way is 48,000 light years. So the dust lane is going to be a few thousand light years across, something like that. So then I feel like I can safely put... So if I put this system on sort of like the inner edge, I can make the orbital axis, and I'll just say average orbital axis because I don't feel like dealing with any like eccentricities and stuff like that. It could be interesting, but I just don't feel like dealing with it, especially since it would sort of mess up the orbit. If the system is going outside of the dust lane, that could be dangerous for life. So if this is on the inside of the ring, I think it's safe to put it at like 29,000 light years from the galactic center. I think that's pretty good. And actually, I can put some just very basic information about the overall motion. Orbits with the dust lane around the central black hole of the galaxy, so it's not going to go like faster than its surrounding dust lane, because that just wouldn't make any sense. And so the orbital period, I could not find anything. I could not find a clear equation, so I'm just going to leave this blank for now. But eventually I might fill this out if I can find some solid research on this. And it's definitely out there, but I don't have the time to look it up right now, sadly. Inclination with galactic plane is kind of weird because, well, there's no galactic plane. Since it's an elliptic galaxy other than the dust lane, so there's no, like, real galactic plane other than the dust lane. I mean, it's going to be in line with the dust lane anyways, so I'm actually just going to delete this section as well, since it doesn't really make sense to have. Which leaves, for the last stuff, just determining these sorts of things and the regions. And this is really just how many dwarf planets do I want, since the names of the planets will be determined later, when I'm actually making the planets, stuff like that. You know, I've already determined where the planets are going to be, how many terrestrial versus gas giant planets, you know. So really all that's left for, on the planet end is dwarf planets. I'll add a comet field, but I'm not actually going to create a number of comets. This field is really only going to be for comets that get close enough to the home planet that it can appear and show up with bright colors and be relevant to the cultures that are on the planet. So I'm not going to fill that out with a number, since I'm pretty sure the number for our solar system is literally in like the tens or hundreds of thousands, so I'm not even going to bother. Dwarf planets, however. Alright, I just did some looking up on the old internet, and I didn't find any solid answers as to like a theoretical estimate to how many dwarf planets are in a system. Through my research, or through my reading though, I found that there are, it's like 7 to 9 basically confirmed dwarf planets in the solar system. There's a few that are on the edge sort of thing, but there are also a lot of candidates that we just need more data for. But obviously this is a very sure thing. And the definition for dwarf planets is also kind of weird. It's not a very well-defined concept. It's basically just a planet that's small enough that its neighborhood is still filled up with a whole bunch of other objects, like a asteroid belt. You can have a planet this size that has a clear orbital neighborhood and is a planet. Like, I'm pretty sure there's a dwarf planet that's almost the size of Mercury. Well, I know that there's a moon that's larger than Mercury, Ganymede. This is a difficult decision to make, but I can always change it in the future, which is why I'm just going to throw out a number. I'm going to say 16. which might seem a bit large, but there are a whole bunch of candidates in our own solar system that we just need more data for. So I think this is a good number. As far as belts go, this is another thing that I can very well change in the next video if I have more research done. But I'm going to put 3 belts. I'm going to have a belt here, here, and here. That's what I'm thinking. In here, I just have to say, like, so one between planets 5 and 6, another after planet 9, and the third after planet 10. I think that's pretty good. Alrighty, dighty. That is it for this episode. It was hopefully pretty short and sweet. And it might have been kind of underwhelming since I didn't actually make any of the planets in this episode, but, you know, it's a lot of setup sort of stuff that needs to happen. I will start getting into the planets in the next episode. I don't know how many. It depends on how quickly the planet descriptions, I can get through those. There's a chance I might only be able to get through a planet per episode, so it might take a little bit for me to really get into the actual home planet that I'm going to be visiting for the rest of the series. Get excited for that. So since I am expediting time here and I want to make producing these videos easier so that I can get them out quicker, I'm actually going to discontinue the Relial snippets at the end of videos. I may or may not get rid of it for the previous episode. We'll see. And this will hopefully be temporary until I have more time, and if y'all like them enough, I will bring them back. Mark my words. But as for right now, I'm just going to discontinue them since that's simpler. So yeah, I will see y'all in the next episode. Farewell.